This video is going to look at solving a system of two linear equations and two variables using the elimination method. Now, the book does also mention using the substitution method, and although either of those methods will work to solve any 2x2 system of equations, I'm going to show the elimination method because I think in the end it's a little bit easier. And the way it works is my goal is to take these two equations and somehow manipulate them so that instead of having x's and y's, I can spit out an equation with just x or just y, allowing me to solve for that one variable and then go plug it in to solve for the other one. And the way it starts is by making sure everything's lined up. Notice in this equation, or this system of equations, things aren't necessarily lined up. So the way I'll do that, noticing that I have this y term on the right side, and I'd rather not have it on there. I'd rather have it on the other side so it's lined up with the other y. I'm going to subtract it, making the new top equation 2x minus 5y equals 6. And the bottom equation will stay, for now, 3/4 x minus y equals 4. So now I've got all my x's and y's and constants, everything's lined up. But before I begin the elimination method, let's go ahead and try and get rid of that fraction on the bottom as well. I'd rather not have that 3/4 there. And so using a method described in Chapter 1 to get rid of that fraction, let's go ahead and multiply through this equation by the LCD of that equation, which of course is just the only denominator 4. So I'm going to multiply through by 4. And if I do that, now I'm going to leave this top equation alone. I'm going to leave the 2x minus 5y equals 6 alone. On the bottom, though, I'm going to multiply through by this 4 over 1. And what's going to happen is the 4 times the 3/4, the 4's will cancel, leaving just 3x. 4 times the negative y is negative 4y, and 4 times the 4 is 16. So now what I have are two equations that are, basically identical to the original ones, but now they're, both in standard form, everything is lined up, and there's no fractions. Now I can actually start working on solving the system of equations. And the way that works is to try and rewrite these where either the x terms or the y terms will cancel themselves out. For instance, as I look at the x terms here, I notice I've got a 2x and a 3x. So obviously those aren't going to cancel if I add them. So what I'm going to do is I'm going to multiply both the top and the bottom by whatever numbers will make the x's cancel. For instance, if I chose a 3 here and a negative 2 there, multiplying these two are going to give me 6x. Multiplying these are going to give me negative 6x, effectively canceling out the x's, which is, would be very good. But that's not the only way you could do that. I could multiply the top by, say, 6, then bottom by negative 4, and that would give me 12, and that would give me negative 12, also canceling them out. So there's really lots of different possibilities here. It's just up to you as to what you want to do. In fact, we could go ahead and try and get rid of the y's. I could multiply the top by 4, and the bottom by negative 5. Multiplying the 4 times this is going to give me a negative 20y. Multiplying the negative 5 times the negative 4y is going to give me a positive 20y. And again, those would cancel out. So it's really up to you how you want to do that. The way I'm going to do this is I'm going to go ahead and try and get rid of the x's. So I'm going to multiply the top by 3 and the bottom by negative 2. Right? If I multiply the top by 3, my new top equation is going to be 6x minus 15y equals 18. Multiplying the bottom equation by negative 2, I get a negative 6x plus 8y equals a negative 32. And now I'm going to go ahead and add these, and if I do, I notice that when I add the x's right here, the fact that they're opposites means they're going to cancel. So adding those, they just go away. All right, adding the y's, of course, negative 15.8 gives me a negative 7y. And adding the constants, 18 minus 32, that's going to give me a negative 14. And all that's left to do now, in this case, is solve for y. And I would do that by dividing both sides by the negative 7. And that would end up giving me y equals a positive 2. So basically, I now have half of my answer. If this were my solution over here, if this was the point of intersection, what I'm looking for, I would know that the y-coordinate of my solution is 2. All I got to do now is find the x that goes with that. And that's the easy part, because once you have one half of your solution, finding the other half is simply taking that y equals 2, what you found right here, and plugging it in to any of the equations that we've got up here, plug it in anywhere there's a y, and use it to solve for the x. For instance, I could go ahead and decide to take that y equals 2, and I could say plug it into, I'm just going to pick one. Let's say I wanted to plug it into this y right here. All right? Just because I want to. If I take it and plug it into that y, then what happens is, into this equation right here, all right, letting y be 2, that's going to give me 3x, and then minus 4 times that 2 equals 16. And then solving for x here, I just get 3x, what's that, minus 8 equals 16. Adding the 8 to both sides, I get 3x equals 24, and then dividing out the 3, x equals 8. And I now have my x coordinate for the point of intersection, meaning that the solution now to this equation, the original system of equations, is the point 8, 2. All right? So it seems like it's maybe a little involved, but it really is in the end fairly simple. We just, again, we took the two equations, we manipulated them to give us a nice set of equations where there's no fractions and everything's lined up. We then multiplied top and bottom by whatever numbers it took to make the x's in this case go away. Could have chosen the y's, but we chose the x's. Go ahead and combine those where you have just a y variable, solve for the y, and then once you're done with that, take it, plug it into any of the y's up above here. I chose this one, and solve for that equation, which then gives you value for x, and set it up next to the y, and you've got your solution to the system of equations. Piece of cake.